Let's take a look at 1.11. Ammonia and hydrazine are both binary compounds of nitrogen and hydrogen. Based on the law of multiple proportions, how many grams of hydrogen would you expect 2.26 grams of nitrogen to combine with to yield ammonia? This yields the law of multiple proportions. They say multiple proportions. This is actually a better example of the law of definite proportions. This says every molecule of a substance is going to have the same ratio of each element by mass, meaning that every molecule of ammonia will always have the same ratio of nitrogen to hydrogen. So we just need to find out what that ratio is. So we're going to ask ourselves, what is the ratio of, actually, we're going to go hydrogen to nitrogen. Make our math a little bit easier there in the long run. What is the ratio of hydrogen to nitrogen in ammonia? Well, I took the liberty of going to the periodic table before we began working this problem and looking up the atomic mass of nitrogen and the atomic mass of hydrogen. And it turns out that nitrogen has an atomic mass of 14.0067 and hydrogen has an atomic mass of 1.008. I'm trying to think of the easiest way to explain this. Okay. In one molecule of ammonia, we have 3 hydrogens. How do I know that? Because of that 3 right there. And each one of those hydrogens has a mass of 1.008 to give me a mass of hydrogen of 1.088. Whoops, punched in wrong. 1.0808 times 3 equals 3.024 grams hydrogen, or actually we're still working in AMU on here. It doesn't really matter. 3.024 hydrogen. We have 1 atom of nitrogen. That 1 atom of nitrogen has a mass of 14.0067 AMU. So we have 14.0067 of nitrogen. So if we're wanting to know the amount, so now we have a ratio. And if we have a ratio, we have a conversion factor. They're telling us that we have 2.26 grams of nitrogen. And they want to know how much hydrogen. So we've got to get rid of nitrogen. So I'm going to place nitrogen down here where it cancels out. 14.0067. All right, I've canceled out my nitrogen. Now I want my hydrogen ratio. According to that we just worked out, it's hydrogen. So now we multiply everything on top, divide through everything on the bottom. For those of you who are wondering about grams AMU, which I kind of glossed over there, if I have AMU here and I have AMU here, anything divided by itself cancels to 1, right? So I can just cross that out, which would leave me with a ratio of 3 hydrogen to 14 nitrogen. And that's what I'm using here. So now I've gotten rid of my nitrogens. I have hydrogen, so I simply multiply everything on top, divide through by everything on the bottom. And that gives me 0.487926 as my calculator lie. So sig figs, 3 sig figs here. So our answer should have 3 sig figs, 1, 2, 3. So our best answer is going to be 4.88 grams of hydrogen. Now they ask us the same thing again for hydrazine. So we're going to repeat the process. And let me see if I can explain it a little bit better on the fly here for the hydrazine one. But for hydrazine, we're going to repeat the entire process. We have hydrazine. And in every 1 molecule of hydrazine, I have 4 hydrogens. And each one of those hydrogens has a mass of 0.08 AMU. I have 2 nitrogens. And each one of those nitrogens has a mass of 14.0067. So that's going to give me a ratio of, running to my calculator now, 4 times 1.008, 4.032 AMU of hydrogen, and then 2 times 14.0067 would be 28.013 AMU of nitrogen. So that's my ratio. My ratio would be 4.032 hydrogen for every 28.0134 nitrogen in terms of mass. That's my ratio in terms of mass. So if according to this problem, drag the problem back on screen here, we're starting off with 2.6 grams of nitrogen. So I've got 2.26 grams of nitrogen. I don't want nitrogen. I need to get rid of my nitrogen. So I place nitrogen down here. I'm wanting hydrogen. In the context of hydrazine, I know that for every 28 parts of mass nitrogen I have 4 parts of mass hydrogen. So I multiply everything on top, divide through by everything on the bottom, and that's going to give me 2.26 times 4.032 divided by 28.0134 gives me 0.32528. I've got 3 sig figs here, so I should have 3 sig figs in my answer. So 0.325 grams of hydrogen would be needed. And that's it.